Hi everyone. In this video, I want to talk a little bit about radical equations. So, first of all, anytime you have an equation involving square roots, you must check your answer, okay? It's very important that we do this, and we'll see why that's important here in a little bit. So, let's just remember this. You must always check your answer, check your work every single time. Otherwise, you will probably get the wrong answer at least once. Okay, so it's very important that you check your work here. Okay, um, and like I said, we'll see some examples in this video. So let's look at this first example. Here we have 7 is equal to the square root of 13 minus 6w. So to start with, let's go ahead and square both sides. So if we do that, we're going to get 49 is equal to 13 minus 6w. And again, this is because if you square a square root, the square root is just undone. Okay. So now what we can do is we can take 13 away from both sides, and we're going to get that 36 is equal to negative 6w. Now we can divide both sides by negative 6, and we get that w is equal to negative 6. So before we do that, though, we have to go back. We have to make sure that it actually works. So here we have 7 is equal to, I guess we can just start with this side, the radical side. So if we plug in the answer and we get 7 for our result, then we'll know it's correct. Okay, so we'll have 13 minus 6 times negative 6. The square root of that is equal to the square root of 13 plus 36, which is equal to the square root of 49, which is equal to 7. So we know that w equals negative 6 is indeed a valid solution to this equation. Now let's look at 10 minus, the square root of 10 minus 2w is equal to 2. So if we square both sides of this equation, we will get 10 minus 2w is equal to 4. So then we can take 10 away from both sides, and we get that minus 2w is equal to negative 6. From here, we can divide both sides by negative 2, and we get that w is equal to positive 3. Okay, so if we plug in w equals positive 3, we should get 2 back. So let's do that. We have 10 minus 2 times 3. Okay, the square root of that. So that gives us the square root of 10 minus 6, which is equal to the square root of 4, which is equal to 2, which was what we had here. So we are good. That means that w equals 3 is a valid solution. Okay, now we have the square root of 5x plus 24 plus 4 is equal to 1. So we got to start by isolating this radical. So let's take 4 away from both sides. And that's going to give us that the square root of 5x plus 24 is equal to negative 3. Okay, so we can go ahead and stop here, actually, if we want to. We can go ahead and say there's no solution. Okay, that's fine. And that's because we can't have the square root of some number being negative. Okay, so that means we say there is no solution here. We learned about that back when we first started covering square roots, so I won't spend a whole lot of time on that, but we know that we cannot have the square root of a number being negative. So if you end up with any expression that involves a radical by itself on one side and a negative number by itself on the other side, then we know that there is no solution. Okay. So now let's take a look at this one. Here we have the square root of x plus 7 minus the square root of x is equal to 1. Okay, so let's go ahead and see if we can solve this. So to start with, we want to make sure we have one radical on one side and the other radical on the other. That will make our lives much, much easier. So we're going to add the square root of x to both sides here. So that's going to give us the square root of x plus 7 is equal to the square root of x plus 1. And now what we can do is we can go ahead and square both sides of the equation. And that's going to give us x plus 7 is equal to the square root of x plus 1 times the square root of x plus 1. Okay, so that'll give us x plus 7 is equal to the square root of x times the square root of x, which is just x. Okay, then we have plus the square root of x plus the square root of x again, plus 1. Okay, and then we have, let's start combining like terms. Okay, so we'll have, if we move this x from here to here, these will actually cancel. And so now what we have is we have 7 is equal to 2 times the square root of x plus 1. Then we can take 1 away from both sides, and we get that 2 times the square root of x is equal to 6. So we can divide both sides by 2. We get the square root of x is equal to 3. Then we can square both sides, and we're going to get that x is equal to 9. So now let's check to make sure that works. Let's make sure x equals 9 works. So we should have, let's see, 9, the square root of 9 plus 7 minus the square root of 9 should be equal to 1. Okay, that should work here, because 9 plus 7 is 16, so that gives us the square root of 16 minus the square root of 9 is equal to 1, which is the square root of 16 is 4, the square root of 9 is 3, which is 4 minus 3 equals 1, and there you go. X equals 9 is a valid solution for this equation. Okay, how about 10 minus the square root of u equals the square root of u minus 40? Okay, well, we already have one radical on one side and a radical on the other. So let's just go ahead and square both sides here and see what we get. Okay, so that will give us 10. Let's actually do this down here. We have 10 minus the square root of u times 10 minus the square root of u is equal to u minus 40. Okay, but if we FOIL this out, that's going to give us 100 minus 20 times the square root of u plus the square root of u squared, which is just u, and that's equal to u minus 40. So we'll notice that these u's will actually cancel. So if we take this u away here, we'll get these both cancel, and so we're left with 100 minus 20 times the square root of u is equal to negative 40. Okay, so now we can take 100 away from both sides, and we're going to get that minus 20 times square root of u is equal to minus 140. So now we can divide both sides by negative 20, and we get that the square root of u is equal to positive 7. So if we square both sides, we get u is equal to 49. Okay, so let's check this out. So we have, if we check this, we have 10 minus the square root of 49 should be equal to the square root of 49 minus 40. So that will give us 10 minus 7 is equal to the square root of 9. So we have 3 is equal to 3. So u equals 49 is the solution to this equation. Okay, now we have another one. We have the square root of y minus 32 plus the square root of y is equal to 4. Okay, so let's go ahead and move the square root of y to the other side. So minus the square root of y minus the square root of y, and that's going to give us the square root of y minus 32 equals 4 minus the square root of y. So now if we square both sides, we will get y minus 32 equals 4 minus the square root of y times 4 minus the square root of y. Okay, so if we FOIL out the right-hand side, we'll have y minus 32 is equal to 16 minus 8 times the square root of y. Okay, and then we'll have plus y since negative square root of y times negative square root of y is equal to positive y. So these y's will cancel just like they did before. Okay, and then, so now we have negative 32 equals 16 minus 8 times the square root of y. So we can take 16 away from both sides, and we get that negative 48 is equal to negative 8 times the square root of y. We can then divide both sides by negative 8, and we get that the square root of y is equal to 6. Then we can square both sides, and we get that y is equal to 36. So let's double check and make sure this works. So we have the square root of y, or in this case, it'll be 36 minus 32 plus the square root of 36 is equal to the square root of 4 plus 6 equals 2 plus 6, which is 8. Oh, interesting. Okay, so that is not true, okay? 4 is not equal to 8, and therefore, this is not a solution. Y equals 36 is not a solution, so we would say that no solution is the answer. This is why it's so important to check, because it's not immediately obvious just by looking at this problem that there would be no solution here. So it's very important to check your work. That way, you will know whether or not your solution is right. Because it can be very tempting just to get to this point where it says y equals 36, circle it, call it a good day. But it's really important to go back and check, and then you end up with 4 not being equal to 8. And that shows you that this is not indeed a solution. Sometimes it can be deceptive like that. So it's important to go back and always double check your work, or check your answer at least. Okay, so now let's look at a couple of examples where you have these radical equations that are actually going to turn into quadratic equations, okay? So here we have y equals the square root of y plus 6. So we can go ahead and start by squaring both sides of the equation. That will at least undo the radical, right? So then we'll have y squared is equal to y plus 6. And now we can take y away from both sides, and we can take 6 away from both sides. Okay, and we're going to get that y squared minus y minus 6 is equal to 0. And so the idea here now is we want to see if we can solve this like a quadratic equation, which we should be able to. We want to find two numbers that multiply together to give us negative 6 and add together to give us negative 1. So I'm thinking negative 3 and 2. So this should become y minus 3 times y plus 2 is equal to 0. So we have y equals 3, y equals negative 2. And these are two possible solutions for this equation. And we have to check both of them. That's very important that we actually check both of them. So let's plug in y equals 3. Let's start there. Okay, so for y equals 3, we will have, let's turn this off. Okay, so we have 3 is equal to the square root of 3 plus 6. Okay. 3 is equal to the square root of 3 plus 6. Or in other words, we have 3 is equal to the square root of 9, which is just 3 equals 3. So y equals 3 is a valid solution. Okay, and now let's try negative 2. So we have negative 2 is equal to the square root of negative 2 plus 6. Okay, well, you should already notice that this is already a problem, right? Negative 2 cannot be a part of this solution because a square root cannot be equal to a negative number. So we're going to say that y equals 3 is the only legitimate solution here. Okay, now let's take a look at the square root of 9v minus 14 is equal to v. So let's go ahead and start by squaring both sides. And that's going to give us that 9v minus 14 is equal to v squared. Okay, well, if we set this up like a regular quadratic equation, we can get to v squared minus 9v plus 14 is equal to 0. Okay, and then from here, all we have to do is solve it like a normal quadratic equation. We want to find two numbers that multiply together to give us 14, that add together to give us negative 9. So here, I would think we have negative 7 and negative 2. Negative 7 times negative 2 is positive 14, and negative 7 plus negative 2 is negative 9. So we can write this as v minus 7 times v minus 2 is equal to 0. So from this, we have that v equals 7 and v equals negative 2 are both possible solutions. Or sorry, v equals positive 2. V equals positive 2 are both possible solutions here. So let's plug it back into our original equation and see if it works. So we have v equals 7. We'll start there. We have 9 times 7 minus 14 should be equal to 7. Okay, well, we have should be 63 minus 14 gives us the square root of 49 is equal to 7, and that is true. Okay, so we say that v equals 7 is a valid solution. How about v equals 2? So we have the square root of 9. Let's label this. So we have the square root of 9 times 2 minus 14 should be equal to 2. Well, this becomes the square root of 18 minus 14 is equal to 2, or the square root of 4 is equal to 2. And that is true. So v equals 2 is also a valid solution for this equation. Okay, let's take a look at one last one. Here we have x is equal to the square root of 2x plus 3. Okay, so let's go ahead and square both sides of the equation. And we get that x squared is equal to 2x. Write this a little neater. X squared is equal to 2x plus 3. We can rearrange this so that we get x squared minus 2x minus 3 is equal to 0. Okay, so now we can try and solve this like any other quadratic equation. Remember, we want to find two numbers that multiply together to give us negative 3 and add together to give us negative 1. And negative 3 and positive 1 should do that. So we have x minus 3 times x plus 1. Okay, so remember, negative 3 plus 1 is negative 2. Negative 3 times 1 is negative 3. So we're good there. And that means that our two possible solutions are going to be x equals 3 and x equals negative 1. Okay, so let's check each of these. So we should have 3 is equal to the square root of 2 times 3 plus 3, which is equal to the square root of 6 plus 3, which is equal to the square root of 9, which is 3. So x equals 3 is a valid solution. How about x equals negative 1? Well, we already have an issue. We have negative 1 is equal to the square root of 2 times negative 1 plus 3. And it doesn't really matter where we go from here because we can't have a negative number being the square root of some number. So therefore, x equals negative 1 is not a solution, and x equals 3 is the only solution to this equation.